So we are, I know it's Friday. Let's focus, okay? We are working with separable differential equations. We finished the whole front, right? Is every equation we have separable? No. Okay. Now, all the ones we are expected to actually solve all the way and do things with will be. Otherwise, we won't know what to do with them, and that's okay. All right, so now let's practice not just separating, but solving differential equations. So we're going to start by taking what we have here and separating it. So I'm going to give you a minute. Go ahead, like over here, I'll go ahead and multiply by dx. dy equals 2x over y dx, right? Then what would I do next? I can multiply by y, right? Because I need everything with y on one side, everything on with x on the other side. Okay, we good with that? So they both have the differentials on them, right? 2x dx and y dy. So now we are going to integrate on both sides. So I'm going to put my little integral symbol here and here. And I'm basically doing it in two different steps. This one I'm integrating in terms of y because there's a dy there, right? So when I integrate y, what does that become? I'm integrating, not taking the derivative. Y squared over what? 2. Y squared over 2. Okay, we agree with that? Equals, what does this become? 2x squared, what? Over 2. Okay, and then what am I missing? Plus c. Technically, there's a plus c on both sides, but I don't need to put it on both sides because I just need to put it on one side and it kind of takes care of everything. Okay, does that make sense to you? And yes, that can be x squared. We'll get there in just a second. Okay, everybody good? All right, so then I'm going to, so these do cancel out. We agree with that? Then what can I do here? If I'm trying to get y by itself, what can I do? Multiply by 2, right? So these canceled out. Maybe I should rewrite it just so. So we got y squared over 2 equals x squared plus c. I don't want to lose anybody here. So I'm going to multiply both sides by 2. Multiply this side by 2. Multiply this side by 2. Now watch what happens here. These cancel out, and I'm going to get y squared equals 2x squared plus c. Tell me what looks wrong about that. I didn't distribute the 2 because c is just some number, right? Do we know what it is? No. So whether c is just, it's some constant. It could be 5, it could be 7, it could be negative 30. I don't know. But if I multiply it by 2, I still don't know what it is, right? It's still just some constant. So it's not that I didn't distribute, it's that it kind of gets absorbed in there. And what you can see in notation sometimes is like, instead of just c, it could be like c sub 1, like it's a different c now, but it doesn't even matter that it's a different c. Okay, we okay with that? And I know that's kind of weird, but whether I multiplied it by 2, divided it by 2, whatever, it's just some constant, and I still don't know what it is, and it doesn't even matter at this point. Okay? We still need to solve for y. So what do I do next? Square root. So I'm going to take the square root of both sides. When I do that, I'm going to get y equals square root of 2x squared plus c, or c1, if it makes you feel better. Right. At this point, yes. So, is this correct? No. What? Plus or minus? Plus or minus? That is math jail worthy, right? Okay? Been in math jail. I'm sure most of you, some of you still on parole from math jail for stuff like that. Mm-hmm. Yep. Okay. All right. So are we good? We took this differential equation. We solved for y as a function of x, meaning I can't have any dy's or dx's in there. So recall, okay, our answer above, this one right here, is a general solution. This is called a general solution because we have this plus c in there and we don't know what it is. And remember when we did the slope fields, that's why we weren't sure like where exactly to draw something without somebody giving us something, because c could be anything. So now we're going to be given an initial condition, like I showed you at the very beginning yesterday. We can say that y of 1 is equal to -3, and then we can find the particular solution, meaning we're finding c so we can get a real, live, actual situation here. So y of, which one is the x value here? 1, and then -3 is the y, right? And so we can substitute it into here, and I can get that -3 is equal to plus or minus the square root of 2 times 1 squared plus c. Then how do I undo a square root? I square both sides, right? So when I square both sides, -3 squared is 9. That's equal to 2 plus c. So what does c equal? 7. Okay. Now, we have a plus or minus here. But in our particular solution, we're not going to have a plus or minus. We're going to have y equals, and then the square root of 2x squared plus 7. And then I need to decide if I leave it like this or if it is the negative version. Here's how we figure this out from this right here. If I substitute 1 in for x, the y I get out with this particular solution is supposed to be negative, right? The only way that's going to happen is if I put the negative out there. Okay, and so we look back at this. That's how I would get that answer out of there, because my answer has to be negative. We okay with that? Y'all are looking at me like I'm crazy. Do we not understand? Yes, okay. Just making sure. All right, so I know that y of 1 equals -3. That's how we found c, right? So when I substitute this in, and I get -3 equals square root of 2 times 1 squared plus 7. Like here, I don't have to square both sides. That's going to give me -3 equals the square root of 9. And in order for this to be a -3 at this point, because we didn't introduce the square root, it was in the equation, this would have to be negative in front of it. That's how I know it's the negative one and not the positive, because of the number that they gave me. My y value has to be negative. Okay? If they had said y of 1 equals +3 or something like that, then this would be the positive one and not the negative one. Yes. Okay. Let me think about it like a different way to say this. Okay. When we write this down, okay, so when we were here, where we just had y equals the square root of 2x squared plus 7. And we were trying to decide if it was supposed to be positive or negative. When I substitute this in, because it all comes back to this y of 1 equals -3. Now remember, there's a difference with your square roots. Here, we had to put plus or minus because we introduced the square root into solving it, yes? If it's already in the equation, like if I just said y equals the square root of 2x plus 3, then that is my equation. I don't put a plus or minus in it when I substitute stuff in, right? We good on that? Okay. So here, it's already here. When I substitute in my 1, I know I'm supposed to get a -3. So I put a -3 here. That's equal to the square root of 2. I feel like I'm saying the exact same thing in the exact same way because I don't know how else to say it. 2 plus 1, this is 9, right? So if -3 is equal to the square root of 9, that in itself is not a true statement because that's going to give me 3. The only way to make this a true statement from my given initial condition is to make this negative. That's why it's the negative part and not the positive part. Does that help? Okay. Thank you for asking me to repeat things. I'm trying to understand. All right. So on this next one here, we're going to solve for y as a function of x. We have y prime. Not a big fan of y prime, especially when we're doing differential equations. We want to rewrite that because y prime is the same as f prime of x. And this is the same thing as dy dx. So I'm just changing that to dy dx. Okay. That equals x squared times the square root of y, like that, right? It's just a different way to notate it. This is the way we can actually separate things. Okay? So y'all separate this. You can do it. Y'all got really good at this yesterday. What? Well, right now you're just separating. You're just separating like we did yesterday, which means I would end up with 1 over the square root of y dy equals x squared dx. Everybody okay with that? Okay. So we're separated. We all good with the separating? Okay. So now we are going to end up integrating. So I think I want to rewrite this, the 1 over the square root of y. How could I rewrite that? Y to the what? Negative 1/2. Okay. So I'm going to rewrite that over here. Y to the negative 1/2 power dy equals x squared dx. And then I'm going to put my long s's in here. I want to integrate both sides, so I add 1 to this, which gives me y to the 1/2 power. Then I divide by 1/2, which means I'm really doing what? Multiplying by 2, okay? And then that's equal to x cubed over 3, yes? And then plus c. Now, on the other one, I went ahead and we solved for y before we did anything else. You don't have to solve for y first. We can find c first and then go from there. It's kind of up to you. I have my initial condition right here. So let's just go ahead and substitute that in and see what happens. Okay? So if I do that, I'm going to get 2 times what? Square root of 4, because that's the y value, right? Equals 3 cubed over 3 plus c. All right, so 2 times 2, this is 4. 3 cubed over 3 is really just 3 squared, right? And so that's 9 plus c. What does c equal? Negative 5. Okay? Everybody with me so far? So now we still do have to solve for solve for y, but I can go back and do that now so that I don't have to worry about the weird things that happen with c. I think sometimes people feel a little bit better about that. So I'm going to come here. This is really just 2 square root of y, so I'm going to rewrite it like that, equals x cubed over 3 minus 5. Okay. Everybody okay with that? All right, so now what would be the next thing I do? Well, yeah, but specifically, I got to divide by 2. So this is going to give me the square root of y equals, what does this give me when I divide by 2? X cubed over what? 6, because it's the same as multiplying by 1/2, minus 5/2. Then what am I going to do? Square both sides. So y is equal to x cubed over 6 minus 5 halves squared. Yeah, absolutely. You're not going to need to square that out. But your safe stop can't happen until you actually have y all by itself. And here we do. There's our particular solution. Okay? What questions we got? All righty. Then I want you to try the next one. Let's start. Go ahead and just separate it. So make sure we can separate it correctly. We're okay with that? That's how we got when we got separated. And then I would rewrite this as y to the negative 2 dy equals 4x dx. All right, you go through and see if you can finish this up, unless you have questions on how to get there. Once you have C, let me know. Then what? 1 to the, say that again? Or like an x to the negative 1? Yeah. That's when it's 1 over x. This one's a natural log. Why do you have no? Okay. But it's not 1. Okay. Oh, I see what you're doing. Before you plug it in, I would change that. I would make it 1 over y, negative 1 over y. That way you're not confused. I see what you're saying. I'm sorry. I misunderstood the question. Okay. Good with C. Yep. Yeah, when you get C, let me check your C. You don't have to completely solve for y, but you might want to clean it up before you start substituting things in. Like this, what you have so far, it looks good, but I would clean that up a little bit before I substitute stuff in, or I'm just going to it makes it more confusing, I think. Like what you have, this is correct. However, I would rewrite this before I substituted something in, otherwise you might confuse yourself with something that's not that bad. Where did your minus 1 come from, dear? Oh, no.
Plus 1 to this.
Yeah, but that's y to the negative 1 power. You're adding extra. What the heck is this? Y to the negative 1 is 1 over y, but it's not 1 over y minus 1. Oh, and this, is it because of this guy?
Yeah.
Well, that's multiplying those. So you just make it negative out front.
Okay. So
okay. It's negative. Yeah, there you go. Okay, let me get that far. It is. We already separated it. What do you mean you just go around in circles? We haven't put C in yet. You got to put this in.
I know. Okay. Still doesn't change anything. I don't know how to move it.
And it's not.
I mean 9.
I was like, what the heck are you doing now? Sure there is. Move the parentheses. Legally move the parentheses. Yeah. Yeah. How can you legally move those parentheses? Yep, you got it. Do you know what I meant? Yeah. How are we doing? You get -9? Okay, perfect. Good. Good. And so now that you've got that, now put it back in and see if you can solve for y.
So I got it, but I don't understand like really what happened.
Here, so this -1, that's just what makes it negative out here. Okay, it's like dividing by 1. But anything to the -1 power is just the reciprocal. So the 1 over y comes from the numerator. The negative out front comes from this. Okay, so like x to the -1 power is just 1 over x. Okay, that's okay. How are we doing? Okay, good. -9, good job.
And now I want to.
That looks good. I think that's right. Yeah. Now you want to solve for y. Yeah, so now that you've found c, make sure you put it back in. That's what sometimes people do, and you end up kind of feeling like you're going in circles. You found c. Now you come back up here, and we're going to put it in. So I get -1 over y equals 2x squared minus 9, because c is -9. And then solve for y. While you're working on that, if you haven't already, I'm going to give you the next page. Yes, it's going to go on that page. The page that the other one goes on. All right, so there's a couple of things you can do with this. All right, so the first thing is I could get rid of the negative, and you can do things in more than one step, but so 1 over y would be equal to negative, and then parentheses 2x minus 9. I could distribute if I wanted to, but I can also just leave it like that for right now. Then if I want to get y out of the denominator, I can multiply both sides by y. So 1 is equal to -y times 2x squared minus 9, right? So now that I have that, what can I do to get y by itself? Divide by this, but also the negative, right? Like I got rid of the negative, but now I just need to put it back over there. So I actually want to divide both sides by the negative version of that. So 1 over negative 2x squared minus 9, that's equal to y. You could leave it like this, or you could do negative 2x squared plus 9, or put the negative in the numerator. That works too. If it was still a -1, that's fine. Okay. We all okay on that? Don't tell me you don't know how to do stuff like this. Yes, you do. All right. So we're going to consider this differential equation, right? Why do you have your phone? What are you doing? No, you're not. You're taking pictures of whatever little weird thing you just did. Okay, lie to me. All right, on the axes provided, we're going to sketch a slope field for the given differential equation at the 12 points. Go for it. Sketch this slope field. Don't tell me no. If you don't remember, ask your neighbor. I'm just going to rewrite this equation so that I can see it once I scroll. Otherwise, I'm not going to see it. What's happening on the y-axis? What's happening on the x-axis? Undefined, so we don't write anything. There would be an asymptote on the, it would be an asymptote on the x-axis since it's undefined. Or this, yeah. All right. Are we good with this so far? Yes? Okay. I know you don't love them, but hopefully they're not crazy hard. B says, let y equals f of x be a particular solution to the differential equation with the initial condition of this right here. Write an equation for the line tangent to the graph of f at this point and use it to approximate this. All right, so do I need to separate this at this point? No. Is it asking me to solve this? No. What did it ask me for? Yeah, it says write an equation for the line tangent. As soon as you see that, what are you supposed to write? Point and slope. Okay. Point and slope. Do we know our whole point? 1, -1, right? 1, -1. And then our slope is the derivative evaluated at 1, or evaluated at this point right here. So really, this is going to be dy dx evaluated at the ordered pair 1, -1. Have you already found that? You really did, right, when you did the slope fields? If you don't remember which one it is, that's fine. We can substitute this in, and we're going to get -2 times 1 over -1. And what does that give me? 2. All right, so write the equation of the tangent line. Are we finished with part B? No, because then it says, and use it to approximate this. So do that. I'm going to approximate f of 1.1 using the line that you just had. All right, some of you would lose all credit because your notation is hideous, and I don't know whoever taught you math. Some of you would lose some of the credit because you didn't do this. Approximate. So those of you that did, good job. Then we do 2 times 1.1 minus 1. But you also had something on the other side. I don't know what you were doing, but it's probably... You're also not paying attention because you're over there giggling. Should I go any farther? No. Stop. Can you go farther? Yes. Should you go farther? No. Okay? We good? What questions you got? All right. So now it says find the particular solution. Find the particular solution, y equals f of x, to the given differential equation with the initial condition. So now what do we need to do? Separate. Okay? So dy is -2x over y dx. and go from there. Oh. You make it up now? Oh, you put it in the wrong place, yeah. Well, but there's a negative outside of it, though. I think maybe that's what. See, it's negative x squared, but it needs to be on the outside, not on the inside. No, because now once you square that, then you put it negative. Yeah, there you go. That's what I would do. A lot of times that will make things a little bit easier. Not really. I didn't distribute a negative anywhere. The negative, it's because this was negative x squared. Where, from where? Okay, but I'm not 100% done either.
Because you multiply the 2 over, right? And that, you distribute that too.
Well, I distribute the 2, yeah, but so that's still a negative.
That's why I said where do you get the negative 2 from?
Oh, because negative x squared times 2 is negative. Okay, got it. No. You can leave yours like you have it. You're fine. But we're still not 100% done because I can't have 2 answers. I can only have 1. So this is one of those times where I have to decide, is it plus or is it minus, because it is not both. So my initial condition is f of 1 equals negative 1. If I substitute a 1 into this, my y value has to be negative. Therefore, what does this sign have to be? Negative. So this would have to be y equals negative square root of negative 2x squared plus 3. And the reason Carolina was asking a question, she has y equals negative square root of 2 times negative x plus 3 halves, and that's perfectly fine too. She just didn't distribute her 2, and that's totally fine. Okay? What questions you got? Okay. So I'm going to, I kind of wanted to do one more, one that's on your assignments. Because I think, yeah, let's at least get it started together. Oh my God. Oh. So I don't even have this question written up here, but look at 2000 number 6. So I think if you open it up. Okay, it's on the second piece of, it's because I didn't do it front and back. Second piece of paper, the top question there. So what they've given you is dy dx equals 3x squared over e to the 2y. And it's telling us to find a particular solution, and it gives us f of 0 equals 1/2. Okay, we'll do what we can do on this one. All right, so the first thing we need to do is separate it. So go ahead and separate it. You can separate it without me. And not that I want you to necessarily take a bunch of shortcuts or anything. I did skip a step there and kind of did it all in one step, and that's okay if that makes sense to you. But again, if you're afraid you're going to make up math, then I would avoid that. Mm-hmm. Okay. Anything else? Did we all get it separated okay? All right, so now we're going to throw this in here. All right? And when I go to integrate this, what do I need to do? Okay, but is there a reverse chain rule? If I'm taking the derivative, it is totally chain rule. If I have a function inside of a function and I'm integrating, what did we do when that happened? Okay, we split it if we could. We can't split it, so that's a possibility. If we have a function inside of a function and we are integrating, like I know if I just have e to the x, I integrate, I get e, what is it? Mm-hmm. Mm-hmm. Okay, but you have to have a process that's going to work with everything even when it's not e. What is that process called? What did we do? What? U substitution. So on the left-hand side here, what would u equal? 2y. So du equals what? 2 dy, right? So this is a 2 dy, so I have to multiply a 2 in here, which means a 1/2 out here. So this will give me 1/2 times the integral of e to the u du. Do I need to do u substitution on the right-hand side? No, I can go ahead and integrate and get x cubed over 3 plus c, right? Okay, so when I integrate e to the u, what do I get? E to the u. So this will be 1/2. Oh, I did. Thank you very much. Sure did. Thank you. So 1/2 times e to the u, that's after I integrated, equals, then now my 3's will cancel out, and I get x cubed plus c. And then I have to replace my u, right? 1/2 e to the 2y power equals x cubed plus c. Okay. We okay with that? Yes? All right. So we are going to stop here.